Alright guys, so today we are going to be talking a little bit about transformations of parabolas. So, excuse my dog squeaking his toy. Okay, so transformations of parabolas. So the base equation of a parabola is, where's my pen? Is y equals x minus h squared plus k. And then what the h and k represent is the vertex of that parabola is at hk. So basically last year, the way that we discussed it is whatever is being added or subtracted to the end, that number is what we're going to consider it moving the graph up or down. So since it's a plus sign, this parabola has been moved up 3. When I say up 3, I mean from the origin. So like in a regular parabola, the origin, the parent function of the origin, it would be at 0, 0. So in that parent function, the vertex is at 0, 0. And so then going from the parent function to this function, it's been moved up 3. And then the minus 4, since inside the parentheses we have the x minus h, that means that it kind of moves the opposite of what you would think. So if it's a minus, that actually means it moved right 4. And so use the opposite of what you think whenever it's on the inside. So minus moves it to the right, and plus moves it to the left. So whenever you're inside parentheses. And then on the outside, the plus moves it up and the minus moves it down. And so we went over that pretty good in Math 3, I believe. I don't know how far your Math 3 class got, so I can't say that you necessarily went over it. But this is basically how you can tell what transformations have been made to a parabola, just essentially by looking at if it's been moved left or right. Of course, if there was like a negative sign out front or something like that, then that would move it, or it wouldn't move it. It would reflect it over the x-axis. And there are other types of transformations, but for the purposes of this one, it's just been moved up 3 and right 4. So then moving on to this one, very similar. On the inside, you have a plus 4. That means it was moved to the left 4. And then the plus 3 on the outside on the end means it moved up 3 from the origin. And I think there are a few more examples like that. So this one has the plus 4, so it moved left 4. And then it has the minus 3, so it moved down 3. So you guys get the point on this type of problem. But then you come across something like this. And so if we need to put this in transformation form to be able to see where the vertex has moved to, then the way that you do that, I don't know why this keyboard came up. The way that you do that is by completing the square. So we did completing the square a little bit last year. You probably did it with circles. I guess honestly, if you did it at all, I don't know how many of the Math 3 classes made it to the circles unit. But basically, you have in front of the x squared, if you have any coefficient, that would be considered an a. The number in front of the plane x is considered the c, and then the minus 2 is considered c. I think I said the 6 was c, but it was supposed to be b. So you have the coefficient in front of x squared is a, the coefficient in front of x is b, and then the other number, the constant, is c. So, and then the first step is always to set the equation equal just to 0. And then the next thing you're going to want to do is move the constant over. So right now we have x squared plus 6x minus 2 equals 0. So I want to move the constant over first and get that out of the way. And I would have x squared plus 6x. And then what I want you to do is put plus a blank. And we need to put another number there to make this whole equation on the right-hand side a perfect square. And so then I moved the negative 2 over, so I'm going to have a positive 2 on this side. And since I added a blank on the left-hand side, I need to add a blank on the right-hand side. So the next thing that you have to do is to fill in the blank. So I'm going to try to write some notes over here as we go. So the first thing we did was set the equation equal to 0. The second thing we did was move the constant and leave a blank. And you leave the blank on both sides. So the objective that we're trying to do now is to get this right here in some form that I can write parentheses x plus or minus a number and then square it. That's what we want on that left-hand side. So the way that you get the number in the blank is, and this is just a rule that you guys will have to remember, you take the b value. So the b value in this case, it was the 6, so the number in front of the x. Take that b value, divide it by 2, and then square it. And so I realize that's kind of weird, but it's just a rule you're going to need to remember. So whenever we do that, we have that b value divided by 2 squared. So in this case, we have 6 divided by 2 squared. So that's going to be 3 squared, and we're going to fill in that blank in this one with a 9. So then we need to, the next thing we need to do is you're essentially going to factor the left-hand side. So when I say factor, I really just mean you need the same factor twice. That was the whole point of filling in that blank with that 9. So you would be looking for two numbers that multiply to 9 and add to 6, and they should be the same number. So typical rule is the thing for your factor, so your x plus a number, whatever this b divided by 2 thing was, whatever it was before you squared it, that's always going to be the number in your factor. So in this case, b divided by 2, so 6 divided by 2, that was 3. So you're going to have x plus 3, and then it's going to be squared. And then, so you're going to factor the left-hand side and simplify the right-hand side. And so whenever I say simplify, where I have that 2 plus 9, I just want to actually add them together. So 2 plus 9 is 11. And the last step is to move whatever constant you have over there. So in this case, 11. So you're going to move that back over. So move constant back over. And so whenever I move that back, I'm going to have x plus 3 squared minus 11. And then that's going to be that whole equation, and so I'm going to put it back as y equals. So essentially, this equation and this equation that we had up here at the top, that y equals x squared plus 6x minus 2, those two are going to graph the exact same thing. The only thing that is beneficial with this equation is you can easily tell that the vertex of the equation was moved left 3 and down 11. So that's the whole point of completing the square to get it in this form, is to be able to tell what transformations were made to that graph. So these steps, you're going to want to write them down, and hopefully you were able to do this last year, so this is kind of just like review. I know that it probably wasn't done in this exact same way last year, but hopefully you've at least seen it before. So go ahead and write down the steps, and then I'm gonna do at least one more example in this video, and then we can do more in class as well. So, and I'm not gonna write down each step this time, but first I'm just going to go ahead and set this equation equal to 0. And then the next thing I need to do is move that constant over. So I need to get rid of that 9. So I would have x squared minus 4x plus some blank right here equals, when I move the 9 over, it becomes negative, plus the same blank so that I can leave it as a balanced equation. Then the next thing I need to do is take that b value, and I need to do negative 4 divided by 2 squared. So that's that b divided by 2 squared. So then I'm going to get negative 2, square it. Negative 2 times negative 2 is 4, and that's the number I'm going to use to fill in the blank. So then I need to factor my left-hand side. So x squared minus 4x plus 4, that's going to factor to x minus 2 squared. So if you come back and look at this number, that b divided by 2, it would be negative 2, and that's what we filled in right here. So we would have x minus 2 squared, and it is going to equal negative 9 plus 4, which would give us negative 5. And then we're just going to move that last constant back over. And so we would have x minus 2 squared plus 5, and that would be our new equation. Is that right there? And then you can tell from that the transformations. The minus 2 on the inside means that it moved right 2, and then the plus 5 means that it moved up 5. So then whenever you see something like this, as of right now, it's not super complicated, but whenever you have to complete the square with it in this form, it gets a little more complicated. So I'm not going to worry about writing it in standard form. Ignore that part. We're just going to name the transformations. So the 2 that's right here on the outside, that, if you remember, is going to be called a vertical stretch, and it's by a factor of 2. So I'm going to write vertical stretch of 2. The minus 1 still plays the same role that it did before. It moves us to the right 1, and then the minus 2 is going to move us down 2. So these are going to be the transformations made. Where it starts to get tricky is, and I think I have an example in here. Yeah, is when you have something like this, where you have to name the transformations, but it's not in transformation form, and you have some a value right there. So it gets a little bit tricky in this case, but I'm going to show you how to do it. So you're still first going to start by by setting it equal to 0, and then moving the constant over. So I'm going to start with 2x squared plus 4x, and then I'm going to have some blank, and then it's going to equal negative 9 plus the blank. So then this is where it gets a little bit weird. What we're going to do is we're going to take whatever coefficient we have in front, whatever that a value is, and we're going to factor that out to the front of the equation. So we're going to put the 2 out front on this left-hand side, and then we need the x squared on the inside plus, we're factoring a 2 out of that 4x, so it's going to be plus 2x plus our blank, and then it's going to equal negative 9 plus a blank over here. So then to find the blank, we're going to just use this equation, and we're going to still do that b divided by 2 squared. So it's going to be, in this case, 2 divided by 2 squared. And then that would be 1 squared, which is just 1. So the blank in this case is 1. But what you have to be careful about is this blank on this side. So on the left-hand side, we're adding the 1 in the blank, but that 1 is going to eventually, whenever you distribute, be multiplied by that 2 in the front. So whenever you're adding it on the right-hand side, you have to multiply the blank by the number out front. So it's going to be a 2 times 1 in the blank on the right-hand side, just because this blank on the left-hand side is also being multiplied by the 2 on the outside. So then you're still just going to factor what's in the parentheses. So it would be 2 times the x squared plus 2x plus 1 is going to factor to x plus 1 squared equals negative 9 plus 2 times 1. That's just going to be 2. So negative 9 plus 2 is going to be negative 7. So then, just like in the past, you're going to move the constant back over and get 2 times x plus 1 squared, and then when the 7 moves over, it's going to become positive. And then that would be your new equation. So this equation here should be equivalent to this equation here. And so then, whenever you're naming the transformations, there's a vertical stretch of 2, and it moved to the left 1 and up 7. So, basically the only difference in this one is that you factor the a value, so that 2, out to the front after you move the constant over. And then whenever you're working with the blanks, just make sure that you multiply the blank on the right-hand side by that coefficient that you factored out to the front. Okay, so what I would like for you guys to do now is for you to go ahead and try this example on your own. And then, so just like pause the video and try it, and then I'm going to go ahead and do it too, and I'll talk you through it. So you can unpause in a minute, and hopefully you got the right answer. So first thing we're going to do is set this equal to 0. So I have negative 3x squared plus 24x minus 11 equals 0. Then I'm going to move my constant to the other side, and I have negative 3x squared plus 24x plus a blank equals 11 plus a blank. And so then I'm going to factor the negative 3 out to the front. So I'm going to have negative 3. I'm going to open up my parentheses. If you factor a negative 3 out of negative 3x squared, you're just going to have x squared. If you factor negative 3 out of positive 24x, then you're going to have to change that positive to a negative, and then factor 3 out of the 24 is going to be 8x plus our blank equals 11 plus, and I'm going to go ahead and put that negative 3 times the blank so that I don't forget to multiply that constant by negative 3. So then to get the number to fill in the blank, I'm going to do negative 8 divided by 2 and square it. So that would be negative 4 squared, which is 16. So I'm going to fill in the blank with a 16 on both sides. And so then I would have negative 3 times, and I'm going to factor this. It should turn into x minus 4 squared equals 11 plus negative 3 times 16. I'm going to go ahead and simplify that. So negative 3 times 16 is going to be negative 48. So that would be like, oh, no, sorry. So that would be like 11 minus 48, which is negative 37. So all of that is going to equal negative 37. And then I'm going to move that negative 37 back to the other side. So I would have negative 3 times x minus 4 squared. Oh, sorry, I didn't mean to write an equal sign. Plus 37 on this side. And then it would be y equals all of that. So whenever I'm actually naming the transformations, the negative sign out front is a reflection over the x-axis. So that's just where it like flips it upside down, if you guys remember that. And then the 3 is a vertical stretch of 3. The minus 4 inside the parentheses means it's going to move to the right 4. And then the plus 37 on the end means it moves up 37. So hopefully you guys were able to get that. And if you need more practice on this, just let me know and complete the completing the square homework assignment sheet.